Hey guys, I'm going to show you how to use a tree diagram or set up a tree diagram for a probability problem. This is an acceleration topic, by the way. Okay, so here's a problem. It says a bag contains 5 blue marbles and 3 red marbles, and 2 marbles are selected without replacement. So draw a tree diagram showing all possible outcomes and the probabilities, and then find the probability of selecting some certain outcomes that the question is asking us about, and then finally repeat questions A and B, except we'll consider a scenario with replacement. All right, so let's get started. If I were to draw out a tree diagram to describe the outcomes here, well, in my first event, my first selection, so here's my bag, I reach in for the first time and I select out a marble. There's 2 possibilities. I'd get a blue marble or I get a red marble. So that's my possible outcomes. We can talk about the chance of these possible outcomes too. The chance of me selecting a blue would be 1, 2, 3, 4, 5 out of 5, 6, 7, 8. It would be 5 out of 8 because there's 5 blue marbles out of a total of 8 in that bag. Chance of me selecting red would be 3 in 8. Okay, so that's my first event done and mapped out. Now my second event. If I select blue in the first event, and then I reach in to select another marble, my possible outcomes again are going to be blue and red. I reach in for the second time, I might get a blue or a red. Same thing here. If I select a red on that first round, and I reach in for a second time, next round I might also possibly get a blue or a red. So blue or red. Let's talk about the probabilities in the second event now. So for my second selection, if I get a blue, given I got a blue in my first selection. So let's say first selection, I picked out a blue. Now second selection, what's the chance I get a blue again? Well, there's 4 blue out of now 7 total marbles. So it's going to be 4 in 7 chance. Using that logic, if I select a blue in the first round, there's only going to be 7 marbles in the bag, but there's going to be 3 red ones. Okay, if I select a red in the first round, there's going to be 7 marbles in the second event, and there's going to be still all 5 of those blue ones in the second event. Okay, and if I select a red in the first round, it's going to be 7 marbles in the bag, and we're going to have only 2 of those reds left because I've already picked one and taken it out. Okay, so we've got a tree diagram and we're showing the possible paths we can take. So for example, we can go along this path and select 2 blue marbles, or we could go along this path and select the blue then a red. So it's kind of mapping out our outcomes, but we need to still state each outcome. So we'll go through and say blue blue, blue red, red blue, red red. Okay, so this is our sample space, all of our possible outcomes, and we can go ahead and take this a step further and give the probability of finding each of these outcomes. And we should do that every time we draw up a diagram of every time we do a tree diagram. So the way we find these probabilities, we just multiply the probabilities along the tree. So for BB, I see my first event, chance of getting a B, 5 in 8. My second event, chance of getting a B, 4 in 7. Chance of getting B, then another B, 5 on 8 times 4 on 7. That's 20 on 56. And of course, if we can, we should be simplifying 10 on 28 and 5 on 14. All right. Blue red now. Probability here is going to be 5 on 8 times 3 on 7. That's going to be 15 on 56. And I don't think we can simplify that, but I could be wrong. Let me just check. 56 divided by 3. No. Okay. Red then blue, that's going to be 3 on 8 times by 5 on 7. It's going to be 15 on 56 as well. Finally, red then red, that's going to be 3 on 8 times by 2 on 7. This is going to be 6 on 56. And we can simplify this to 3 on 28. Okay, so we've gone through, found out all of our possible outcomes, our sample space, and we found the probabilities of each of these outcomes. Okay, so now B, finding the probability of selecting a blue marble followed by a white marble, well, a red marble, a blue marble followed by a red marble. Well, we found that's this outcome here, and we found the probability of that to be 15 on 56. So this will be 15 on 56. 2 blue marbles. Well, there's only one outcome where we get 2 blue marbles. That's this guy. And the probability of getting that outcome is 5 on 14, which we found earlier. So this will be 5 on 14. Exactly 1 blue marble. Well, there's 2 outcomes where we get exactly 1 blue marble. This one and this one. So there's 2 outcomes. We could achieve either of these 2 outcomes to get exactly 1 blue marble, right? So the probability that we get exactly 1 blue marble is actually going to be these 2 probabilities summed together to give us 30 on 56. And of course we can simplify that. That's going to be 15 on 28, I believe. But yeah, if we're looking for exactly 1 blue marble, well, there's 2 outcomes where we have exactly 1 blue marble. So the probability of this event here is going to be the sum of the probability of those 2 events. Okay, and now if the experiment is repeated with replacement, find the answers to each question in part B. So all we need to do now, we just need to draw up a new tree diagram where we are talking about picking a marble and then we'll replace it back later. So again, our first 2 options or outcomes will be blue or red, 5 in 8 chance, 3 in 8 chance. Now, if I pick a blue marble in the first event, I put it back, well, I'm going to have all the original marbles in the bag in the second event. So my chance of picking out a blue, well, there's going to be still 5 blue marbles out of a total of 8. If I pick a red, well, I'm still going to have my 3 red marbles, but I put back my blue marble, so it's going to be out of a total of 8 marbles. If I pick a red in the first round, then I put it back to pick a blue, I would have, I would have a 5 in 8 chance still. And for a red, I would have a 3 in 8 chance because I pick out that red and then I put it back. So my marbles are in their original state from event 1. Probabilities are the same. So that's kind of an interesting thing. Without replacement, the probabilities kind of change. Depending on what I pick in event 1, it'll affect the probabilities in event 2. But with replacement, our probabilities seem to be the same, right? Okay, now we can list out our sample space. Again, it's going to be the same. BB, BR, RB, and RR. And we can find the probabilities by multiplying up along the branches. 518 by 518, that's 25 on 64. I don't think we can simplify that. 518 by 318, that's going to be 15 on 64. I better double check to see if we can simplify that. I don't think we can. Maybe we could, but you know, we're just learning right now. But for RB, probability is going to be 518 by 318 is 318 by 5 by 8. So same probability as above. Again, I don't think we can simplify that. Finally, for RR, that's going to be 3 on 8 by multiplied by 3 on 8. So 9 on 64, and let's see. Now, I don't think we can simplify that either. Maybe we could. I don't know. I'm rushing a bit. But anyways, that's us done. We've got slightly new probabilities, haven't we? Oh, so if we're talking about a blue than a white marble, a blue than a red marble, excuse me, it's going to be 15 and 64. Previously, it was 15 and 56. So slightly lower chance of us getting a blue than a red. And that makes sense, because if I pick out a blue in the first, and I don't put it back, there's more chance of me picking out a red in the second, right? Because there's less blues to pick from. But if I put that blue back, then it's like the same chance of picking out that blue again, you know? Or there's more of a chance of picking out blue because I'm putting the blue marble back. But anyways, yeah, that's me rambling again, I think. The last thing I'll say is just exactly one blue marble. It's going to be the same thing. We just need to sum up these probabilities. 15 on 64 plus 15 on 64. That's 30 on 64. That's 15 on 32. Alright, we are done. That is us using a tree diagram to describe the sample space and probabilities of events, two events that occur one after the other. And some key points we should take away from this: if we are not replacing it, so for some particular events, event 1 will affect the probability in event 2. In other events, event 1 and event 2 will not have an impact on each other's probabilities. Okay, signing off.
Frozen pizza, a buy. See you next time.